today you are at the New Hampshire Advantage of Thermal RECs webinar, sponsored by Frolin Energy. But the presentation today by Charlie Niebling, and we'll get started on that in just a moment. Right now, I always like to tell you who Frolin Energy is. If you haven't been aware of us, is that we're a mechanical contractor. We're based in Keene, New Hampshire, and we're focused on the installation of high efficiency, low emissions commercial boiler systems. And those systems generally go into schools. It seems like that's some 90% of our population here is that, and we have a number of commercial buildings and a really big industrial building that we've done work on, and those are very impressive. But it seems like the schools are the places that we're just always busy as heck, going in and disassembling boiler rooms and reassembling them with new boilers, whether it be chip boilers, pellet boilers, and then even gas and oil boilers we'll put in to complement in a brand new renovated boiler room. Also, the Applegate apartment, you can see the sign here, residential homes, multifamily buildings. That's a big apartment building over in Bennington that we were involved with. So there's a tremendous amount of work that we've got behind us, and we've got these great capabilities that we want to keep on utilizing. We are a self-performing contractor where we're handling all aspects of a boiler system installation. So that means whether it's project management and whether it's we hire subcontractors or what, we're able to put this all together. Even if we have to build a building, we can actually do that and execute it all from start to finish. So that's the idea of a self-performing contractor. And we're there to consult with you about project development, whether you're an engineer, architect, or a building owner, or someone with some form of an interest in something like this, is that we'd be happy to sit down with you and talk about feasibility and get some design going, estimating the value engineering side of things, get the specs going, and just to really help understand, especially because of some of our new technologies, which has to do with these dry wood chips. We're the makers of what we call PDCs. There's also the systems that they get burned in, which we're kind of like the only game in town when it comes to these boiler systems. We'd like to see more people installing them, but it just happens to be that we're at that early stage of the market. We do have another company that does supply the dry chips, and so that's good. We're sort of like the Johnny Appleseed of dry wood chips, and that's been a good thing for the whole economy, because there's a lot of benefits for this particular in between. It's not a wood pellet. It's not a green chip. It's right in between the two. So today, if you're ready, I'm ready here. Today's the show is the New Hampshire Advantage of Thermal RECs. Thermal RECs are a very important part of the energy scene here in New Hampshire, as far as we're concerned, being that heating energy is probably the #1 energy in the state. What are we doing? We're trying to keep our buildings warm all winter long, and that uses up a tremendous amount of energy. And thermal RECs have been a big boon for the renewable side of things. And we've got today Charlie Niebling, who's a principal partner of Innovative Natural Resource Solutions, and was involved in the establishment of these. And you know what, I think I had another screen set up, and I don't know where it went. I must be on the wrong old PowerPoint here, but we'll proceed anyway. I had a nice picture of Charlie that maybe I'll show later. But Charlie is a partner in Innovative Natural Resource Solutions. It's a 3-person consulting firm that was founded in 1994. And Charlie is a forester by profession. He's also the chairman of the board of directors at Clean Energy New Hampshire, which is our state's renewable energy and energy efficiency advocacy organization. It used to be called the New Hampshire Solar Energy Association, then it was the New Hampshire Sustainable Energy Association. So it goes back really a long ways, and has been a great organization for the state for decades. Thanks for Charlie for sharing that. So Charlie lives in Boston, and he's going to tell us the story about the New Hampshire Advantage of Thermal RECs. Charlie.
Okay. Thank you, Jim. Thanks for the invitation. Welcome, everybody. In a moment, I'm going to tee up some slides here, but before I do, I just want to make it clear that the presentation that I'm going to do is sort of intentionally and necessarily high level. It can get very technical, and I would be delighted to speak with anyone offline, as I'm sure Jim would, about the technical nuances of qualifying for and benefiting from New Hampshire's first in the nation comprehensive thermal renewable energy certificate program. But it's going to be fairly high level. I'll move through these slides rather quickly. If you have a question, point, feel free to interrupt using the chat function. And I'll probably take 15 or 20 minutes and then we'll open it up to questions. So Jim, I'm going to tee up my slides. We're going to talk today about thermal RECs, or T-RECs, as we call them and as they've come to be known. As Jim mentioned, I'm one of three partners in a consulting firm founded by my partner, Charlie Levesque, in 1994. My other partner is Eric Kingsley, who lives in Portland, Maine. Charlie lives in Antrim. I live in Boscawen, so we're New Hampshire and Maine based, active throughout the Northeast. And I would say our principal expertise is in forestry, economic development, natural resource policy, renewable energy, and the nexus between all of those. So we'll proceed. A little history. New Hampshire was an early state, but by no means the earliest state to adopt a Renewable Portfolio Standard, which it did in 2007. There are now, I believe, 31 or 32 states in the District of Columbia that have RPS programs that require retail service, electric service providers to meet a certain percentage of their electricity supply from qualified renewable sources. The original RPS did not include a thermal, but there was considerable debate about it at the time the legislation was going through the process, and an understanding of the interest in broadening the scope of the RPS to include more than just electricity, in effect, make it a more comprehensive renewable energy standard. The original enabling legislation did direct the PUC to study the idea, which they did. They issued a report in 2011 that basically said, yeah, it's feasible. And the legislature took that and ran with it through the passage of Senate Bill 218 in 2012. New Hampshire became the first state with a comprehensive, technology neutral thermal renewable energy incentive embedded within its RPS program. The provision recognizes biomass, whether solid, liquid, or gas, solar thermal, and geothermal technologies. And I'd say the primary talking point that sold the legislature on this, well, there were two. The first was it did make the focus of the RPS fuel and technology neutral, more comprehensive, more outcomes based as opposed to being technology biased. And that, I think, is generally a very laudable policy to pursue when enacting clean energy policy. Basically tell the market what goals you're trying to achieve, and then let the market figure out the most cost-effective way to do that. The other reason is that by adding thermal as a carve-out in the original Class 1 electric class, and Class 1 electric in the New Hampshire RPS is new renewable energy project development, but by adding it as a carve-out as opposed to a new. So in other words, taking a percentage of the original New Hampshire Class 1 RPS obligation and allocating it to thermal, and then setting a much lower ceiling price on thermal RECs, the effect of that change was to significantly reduce the overall compliance cost of the RPS. And that's something that our very Republican legislature at the time was quite supportive of. Anything that could achieve the goal while reducing the cost was seen as a very laudable thing. So that's how it passed. The value of the incentive as enacted, which was effective in 2014 through 2025, which is where the RPS basically plateaus, is approximately $63 million. So it's a pretty significant investment that the lawmakers of the state of New Hampshire opted to make in renewable thermal technologies. And as I indicated, the first systems came online, qualified to receive thermal RECs in 2014. So what is a TREC? Well, when I'm throughout this presentation, I'm going to be obviously talking primarily from my vantage point as someone with some experience in advanced use of biomass to make heat and combine heat and power. So I'm going to be talking primarily about biomass boilers, and in this part of the country, biomass really means wood. But basically, if you've got a boiler, it's making heat. That heat is being delivered to an end consumer. With each megawatt hour of energy that you generate, you are simultaneously producing one renewable energy certificate. One TREC is 1 megawatt hour. A megawatt hour is 3,400,000 BTUs. The rest of the world, besides the United States and the former British Empire, measures heat with watts. We're basically one of the few that still uses BTUs, but the rest of the world has moved on to. That's the way the RPS is structured. So the fact that you can measure both electricity and heat with watts, adding thermal to a conventional electric RPS, a fairly straightforward proposition. Once you have your heat energy has been verified and taken the form of a thermal REC, and that REC is registered with the NEPOOL Generation Information System, which is the regional trading platform for REC purchase and sale and purchase. You've got something, you've got an asset with value. And the main mechanism by which the RPS incentivizes renewable thermal is to require retail service providers in the state of New Hampshire, that's both regulated utilities as well as competitive suppliers. It requires that they meet a certain minimum obligation in the purchase of thermal RECs, and that obligation ramps up over time so that the market can continue to grow and accommodate new entrants. RECs are then sold to an entity that has that legislative obligation through purchase and sale agreements or contracts. They have a certain value in the marketplace based on supply and demand. And once the transaction is complete, the generator of those RECs receives a check from the utility or the competitive supplier, or, as is often the case, from an aggregator who acts as an intermediary to accumulate and aggregate RECs and facilitate the transaction. And that happens typically on a quarterly basis. And it's a fairly straightforward transaction, and it works. Qualifying biomass systems. So basically the law said if your system came online after January 1, 2013, you qualify if you meet certain technical criteria. And that was intentional. They wanted the incentive to be a looking forward incentive to foster new project development rather than recognize pre-existing systems. And that was a very important principle that the legislature insisted on. When it comes to biomass, basically any solid wood fuel, pellets, dry chips, green chips, chunk wood, or a biomass-based liquid fuel or biomass-based gaseous fuel will qualify. There are a couple systems in the state that utilize liquid fuels made from bio-based organic liquids and that have qualified, and I'll talk about those in a little bit. But primarily they are pellet, dry chip, and green chip systems. If the system is less than 3 million BTU, roughly 9/10 of a megawatt in size, they only have to demonstrate that they can meet a combustion efficiency level of 99% or greater. Now that's combustion efficiency, not output efficiency, not to be confused. And it's relatively easy and straightforward for most biomass boilers to demonstrate that they are combusting their fuel with nearly 100% efficiency. If they're greater than 3 million BTU or greater than 9/10 of a megawatt, they fall under Hampshire DES air permitting requirements, and the RPS statute requires that they meet a fairly stringent particulate standard. Most pellet systems can meet this standard without any supplementary back-end emission controls. Most dry chip systems can as well. Green chip systems in general are going to require electrostatic precipitation or bag filtration in order to meet that. And that's a good thing. We want these systems to be clean. We want them to be efficient. We want them to be celebrated in the communities in which they're being installed. And the primary way we do that is that they're operating efficiently and as cleanly as possible. Larger systems, as a result of DES, will also require stack testing to verify the particulate emissions. In New Hampshire, the law requires that the heat output of the system be metered. That the verbiage in the statute is shall be metered, so there's no ifs, ands, or buts around that, although there is a mechanism for people to petition the PUC for alternative methods of verifying their heat output. If the system is under 1 million BTU or under roughly 340 kW in size, they can also demonstrate their output by metering their fuel input. And as yet, I'm not aware of anyone that is doing that, because it's just as technically challenging to meter your fuel input as it is to meter your heat output. And heat output is going to be a more accurate and more advantageous approach anyway. So you can see how we can start to get into the weeds pretty quickly here, but as I said, I'm going to try to keep it fairly high level. I mentioned earlier that the thermal provision is technology neutral, biomass, solar thermal, or geothermal. Now, is generally not economic for systems under about 750,000 BTU or under about 200 kW. And the reason for that is there are compliance costs. There's the cost of the metering. There is the cost of what's called independent monitoring. There is the cost of certifying your BTU meters, which can only be done by a stamped engineer. The aggregation, if you choose to sell your RECs through an aggregator, comes with a fee. And there's a point of diminishing returns for smaller systems. Regrettably, New Hampshire did not make it easy for small systems to qualify, which I think was a mistake. And the PUC staff and the legislature have been loath to change the law to make it easier, except for a few minor tweaks around the edges, but they really haven't amounted to much. Anyway, and I can go into more detail as to why there's sort of a cutoff point below which it's probably not economic for people to seek qualification. I mentioned the compliance costs. Generally, they are going to be less than 10% of gross revenues. And the percentage would be lower for larger systems because many of those costs are basically fixed regardless of the size of the system. So the bigger you are, the lower the percentage will be of your total gross revenues. Still a very beneficial incentive to the owner of the system, even with the compliance costs. And in New Hampshire, if your pellet boiler qualifies for a PUC commercial system rebate, there's also up to $5,000 of additional funding available to help pay for the meters, which will pay for most of the added cost to installing proper functioning and accurate BTU meters. So nice little kicker there from the PUC. After your system is commissioned and operating, you register your system with the NEPOOL Generation Information System. You have to go through an application process with the PUC. It takes usually 30 to 60 days. They're fairly quick about turning those around. You have to have an independent monitor in New Hampshire to verify your heat output. The PUC maintains a list of individuals who are qualified to do this. The last time I looked at the list, I think there are maybe 6 or 8 folks who have the credentials and who have opted to be recognized by the PUC as independent monitors for thermal projects. You start producing and minting RECs. You are reporting your RECs to GIS on a quarterly basis, or your independent monitor is. And either your aggregator or you yourself can then go out into the market and try to find a buyer for your RECs. And I mentioned earlier that in New Hampshire, basically, if you sell electricity at retail as a regulated utility, which means Eversource, Unitil, or Liberty, as the New Hampshire Electric Co-op, or as a competitive retail supplier, you have an obligation to purchase thermal RECs. And the bigger the percentage of the total electric load in New Hampshire that each of these entities represents, the bigger the TREC purchase obligation that they have. It's a proportional allocation. So the big buyers are Eversource, Unitil, and Liberty, and some of the larger competitive suppliers like Constellation. Just a couple examples, and I know Jim is going to show some slides of many of the projects that Froling Energy has done over the years, but say you've got 2 56 kilowatt pellet boilers that are ganged up in an installation, so a total of 112 kW. Probably not a very good example because, as I did say earlier, smaller systems, there's a kind of a point of diminishing benefit. But these systems operating at 85% output efficiency approximately will generate about 240 megawatt hours of useful thermal energy a year and have gross revenues of about $4,800. A 1 megawatt dry chip boiler, or boilers, more likely, multiple boilers ganged up, if using dry chips, heating a public high school with a 6-month heat load and maybe domestic hot water, 80% output efficiency, roughly 2,000 megawatt hours of useful thermal energy a year. At $20 net to the owner of the system, that system is going to generate about $40,000 a year in revenue. And Jim's got some fantastic slides that show what a significant impact that has on your overall operating costs or your ability to pay down your initial capital investment at a much more accelerated rate. Bigger systems, 3 megawatt chip steam boiler with a 12-month process heat load. Maybe it's dry kilns or food processing or a big brewery or something like that. 75% output efficiency, roughly 9,000 megawatt hours of useful thermal energy a year. gross revenues of $180,000 a year. So we are not talking pocket change here. This is a very significant incentive. And I think if more people knew about it and understood the profound implication that it has on the financing economics of your project, more people would be taking advantage of it, even in this era of relatively low fossil heating fuel prices. Results. This incentive, this program has delivered on what the legislature asked it to do. In 6 years, there are 58 qualified TREC generators in the state of New Hampshire. The combined installed capacity of those systems, which are all biomass and geothermal, incidentally, is 53 megawatts. That's essentially equivalent in terms of nameplate capacity as 3 of the commercial utility scale wood-fired power plants. Now they're producing electricity as their primary energy output, not heat, although they are turning off an awful lot of heat into the atmosphere. But nonetheless, this has had a very significant impact in terms of energy capacity and installed capacity in the state of New Hampshire. There are 46 biomass systems, pellets, dry chips, green chips, and liquid bio-based fuels, 22 public schools, 3 college campuses, 4 county facilities, 4 rural nonprofit hospitals, 8 businesses, and a smattering of others. They're using approximately 70,000 tons of low-grade wood annually. That's green tons in direct fuel or dry fuel or as pellets. They're using a significant volume of sawmill residues, which is a really important outlet for the sawmills because they produce a very high-quality fuel chip. These systems are basically spending about $5 million a year on New Hampshire wood and pellet purchases. So that's money going into our economy, not someone else's economy. They've reduced oil consumption by about 3.3 million gallons annually in equivalent heating oil consumption. And most of these systems came online displacing heating oil. And the total benefit to the New Hampshire economy is on the order of $8.5 million. So that's a very significant, and that's annual, by the way. It's a very significant contribution that the program has made. And I and many others have been doing our best to educate and enlighten the legislature about the return on the investment that the policy has made. Well, let's talk about what's going on in the legislature for a moment. House Bill 213 was introduced by one member of the General Court who has a long history of antagonism toward renewable energy and policies and programs that incentivize and support clean energy development in the state of New Hampshire. This is a bad bill. It eliminates the Class 1 thermal incentive. It freezes all of the other classes, renewable energy technologies at their current percentages. It reduces the state's RPS mandate from 25% by 2025 to only 8%. This at a time when every other Northeastern state is adopting much more aggressive clean energy targets through their RPS and through other programs. So the disparity, if this bill passes, between the Granite State and the rest of New England and New York and elsewhere around the country will only grow wider, which has fairly significant economic consequences to New Hampshire. And I won't elaborate on the multitude of ways that puts us behind the 8 ball, but it's significant. And importantly, it eliminates RECs in Class 3 for biomass electric generation. And frankly, the RECs are about the only thing keeping the remaining plants operating. And the plants and the market that they represent for low-grade wood are extremely important to the state of New Hampshire and to the practice of forestry. If you're interested in weighing in on this bill, the committee, the House Science, Technology, and Energy Committee, has a work session tomorrow. You can tune in by Zoom and listen in. You can communicate to the committee with a one-click email. That email address is House Science, Technology, and Energy, one word, House Science, Technology, and Energy at leg.state.nh.us. And a couple sentences to let them know your views on this. They would appreciate hearing from you, many of them, and you can help the cause here. That's it. I'll wrap there and offer to address any questions or comments. Jim, I don't know if you're going to plow through your slides first or whether we should open it up at this point, but whatever you wish.
I think what I'd like to do is start mine, but if people have questions, they can enter them into the chat, and Charlie, you can monitor those, and especially if something's relevant that you'd like to bring in, please do.
Okay.
So there's Charlie in a summer day. Okay, so now you know what he does in summer and winter. So here we are. You have Charlie's email address there, and I'm going to have that a little bit later as well. So if you've got any questions for him for later on, or need some of this information about House Bill 213, please do write. These are the schools that we are aware of. Not all of them, but Charlie said there were some. What was it? How many schools did you say it was? 27 or something like that?
22.
22, okay. 22 schools and public schools. And there's a tremendous number of them. We've worked on them, other people have worked on them, and they've been incredibly successful. I mean, we'll tell you a little bit more about the financial side of this, but the investment is usually about a 7-8 year payback with all things considered. And there's fuel savings, significant fuel savings, as well as the thermal wreck savings. So you can recognize so many of them that whether it's Jaffrey Ringe or John Stark or I know Bethlehem Elementary, all over the state. And there's even more schools. That's right. I have two slides here with the pictures. And the university campuses, Charlie mentioned, we've got 3: Keene State, Plymouth State, and University of New Hampshire. And they all burn 3 different fuels. Keene State burns the vegetable oil, reprocessed, and we did the system at Plymouth State, which burns pellets at the Allwell Center there, this giant athletic facility. And then the University of New Hampshire, on the Thompson School side of things, there's a complex of buildings and 10 greenhouses that are being heated with the dry wood chips. So there's some really good examples in the state here in the schools. There's also a number of businesses. The Warwick Mills over in New Ipswich, Whelan Engineering is a tremendous user. They're offsetting over 200,000 gallons of oil a year, which has just been phenomenal. The Filtrene Manufacturing Company invested over in Keene. The farm at Eastman's Corner is a rather small operation, but they're greenhouses and they're heating them with dry chips. And there's also a business park up in Orford. But businesses taking advantage of these things, there's a lot more potential out there. You can see most of these are rural. That's one of the things to really point out, is that this is a rural fuel, that biomass. It tends to be something where you don't have access to natural gas. Now, there are exceptions, but that's been a very common theme. And what we find is that people that have natural gas say, oh, this is cheap, we're great. In fact, businesses all move into areas where natural gas is. But biomass can be just as inexpensive or even less costly than what natural gas is. So we got to get that message out a little bit more. A very big factor. There's also all these we'll say nonprofits, but we can bulk that in different ways. We can talk about hospitals, and then a place like historic Harrisville, which is actually a semi-profit. They're a landlord with a number of different organizations under their roof. They're utilizing these tremendous old mills in Harrisville. The Society for the Preservation of New Hampshire Forests just put in a system that's operational this winter. You can be able to go see that here fairly soon. In these hospitals, the Androscoggin Memorial in North Conway and Littleton National Regional Healthcare. So really interesting that way. There's a lot of big systems right there doing a lot of work. I'm sure a lot of offsetting of oil. Government operations, the counties have done tremendous work. We've got Rockingham, Sullivan, Cheshire, and Merrimack counties all have their systems that are operational. And, some doing multiple buildings, some like prisons on one hand. And then you've got the Cheshire County, the Maplewood Nursing Home was completely renovated over the last couple of years. And they built a brand new wing. There were two major wings, and then there was this new third wing. And the whole thing now is converted from some big steam boilers that were converting to hot water, and it was very confused and old and ready to be replaced. And boy, we replaced it with a tremendous new boiler system there. So there's real big progress. It's not just changing the fuel, but it's also upgrading these heating systems to be much more efficient than they ever were with any other prior fuel. Charlie talked about what it takes to put in a system. You need to invest in some BTU metering equipment. And this is just gives you sort of an idea. It's maybe a little more complex than most people want to see, but there's basically, this is the boiler here. And then when on the piping, we have a monitor that is looking at temperature in two different locations, both the supply and the return, or the output of the boiler, and then what comes back from the building. And we compare those two temperatures, and obviously the difference then is how much heat the building used or how much we delivered to the building. And that's what we're counting. So the BTU meter registers that. It has to record this like once an hour and give you all this background data. But in the end, someone approves that, and that tells you how much heat this boiler system actually used, which converts directly into the thermal RECs that you've created. There's these electronic sensors here, and then the last thing is the flow meter. You can't just look at temperature in, temperature out. You've got to find out what volume of flow there was at that time as well, and that tells you exactly what your BTU gain was. So, Charlie said what a megawatt of energy is in BTUs. Well, we can look at it really simply and say generally, and it's funny how close this works out to be, but we can always say pellets give you 4 RECs per ton burned, PDCs, or the dry chips, are 3 RECs, and then green chips, 2 RECs. It's pretty steady. Obviously, there's a lot of variation that's possible there, but that's a pretty good rule of thumb to utilize. Here's just a good example now. And there's actually a building, a system that's behind this. And I think that's something to say. This is not just a made up thing. There's somebody that actually did this. But this high school, they're burning 320 tons of dry wood chips. They replaced 30,000 gallons of oil in doing so. So they're generating, in doing that, 972 thermal RECs. They sell those for, let's say, a net of $16 each. And then you end up having the school earning $15,000 just on the sale of the thermal RECs, just for that purpose. That's a pretty big school, but that's a possibility for you. Okay, the next one. This is the same school, but we're looking at it from a slightly different point of view. We're saying, what is the price of oil? You never know what the price of oil is at any given moment, but it seems like right now, $2.30, $2.75. Is it going to be $3? Will it be $4? I don't know, but we'll look at this one right now. $2.30, which is a pretty darn good price right now. And then you buy these chips as an alternative to that oil. And now you can see you've already saved $29,000. And then you have this generating these thermal RECs at another $15,000. So the new annual cost went from $69,000 when they just had oil down into $24,000. Amazing. And imagine if this was $3 or $3.50, which it was not that long ago. And so now you've got this very steady price, which is the amazing thing about biomass. It hasn't changed much at all. I mean, there's basically an inflation increase. So they have this tremendous gain. So they're saving $44,000 a year with a 64% fuel cost savings. That's pretty astounding. Another one was a smaller setup, just 13,000 gallons of LP. And a gallon of LP is less BTUs than a gallon of oil, just for the sake of saying it. So this is a rather small system, but they ended up burning 97 tons instead of those 13,000 gallons. And again, this is the dry chips, and that's what we love, the dry chips. So I keep that in this. But we'll say $12,000 for that. But now they're generating the thermal RECs. $4,600 comes back net. Now, this net, these often sell for about $20 a piece, maybe a little more, $22 or so. But there's fees and different things that come out of that. So we see a net of 16 is actually fairly average. And, you know, some do better, some do worse, I suppose. But now, so their actual net is $7,400. So they have a $17,000 savings. That's pretty good. You know, you can shop around for LP just the same as with the oil is a variable price there. But here's what it looks like. Let's just say it was $1.93 on this first one. Now we'll just look at it $1.20. So now it's only $15,000 a year. Well, biomass, you're only saving $3,500. But then you add the thermal RECs in, and there's still a significant 52% savings. So very interesting. You know, this has been a big impact, and it's helping in so many different ways. But this incentivizing is really what it's all about. The more you burn the other fuel, the better you do. So, you know, we're not asking you to burn more than you would normally, but the idea is that. So let's just look real fast. I've got two charts here. This one shows what it is without thermal RECs, and this one shows it with it. So let's just show real fast. Per million BTU net. That's a good, easy way to compare fuels. There's one where you could say just what's the gross potential of that fuel, but I like to look at what the typical net is. So the net means that that's the amount of heat that a typical boiler would produce with that fuel, a gallon of this or a ton of that. So anyway, here we are, and you can see the pellets are about $18, and that's about the same as oil at $2 a gallon. So pellets are pretty good, really not bad. The $2.45 is, you know, a decent price for pellets. Propane at $1 a gallon is $13, but PDCs are $12. That's just right out of the gate. You know, an oil at $1 a gallon is $9. Green chips right in that range as well. So are we ever going to see $1 oil? I don't think so, but it's possible. It might happen once in a while. What they were paying you to take oil over the summer. Wasn't that the case? That's probably not possible. But here's the next, you go with thermal RECs, and you can see how it drops down. Now you can see pellets go from $18 down to $13. That's pretty good. And another, well, is this one here where you end up with the PDCs at $12 and you go down to $7. So you're getting really close to the price of cheap oil or green chips, and then green chips get even lower. So why would I go with pellets? Why wouldn't I go with green chips for my house? Well, that's kind of crazy. It's a scale thing. Green chips take a big system to be able to justify. These are basically products. If you haven't heard about this before, the more refined they are, the more costly they are, but the easier they are to install and the least cost system. So it's a trade-off a number of different directions. This is just another way of looking at it. The fuel, what's the price of a gallon of oil? This may be even confusing. I like to do this though, because people are used to, what do I want to pay for oil? What do I want to pay for propane? Well, if you're buying wood pellets, you're basically buying oil at $2.04 a gallon. But if you have thermal RECs, it's $1.50. Not bad. You know, on propane, you get it down to $1 a gallon, which would be pretty hard to do. There's people buying, paying $3 plus for propane. So obviously that makes a big difference. This is all for wood pellets. Natural gas, we even get it down to close to $1 a therm. And mostly we could talk about natural gas as $1 a therm. So something to think about. PDCs, again, these are going to be bigger systems, but they're even less money. So you end up, the fuel oil goes from $1.34 down to 83 cents a gallon. Sounds like a price war to me. We haven't seen that forever. Propane then down to 57 cents a gallon, natural gas, 64 cents a therm. That's pretty cheap. And then green wood chips get even cheaper still. So it's pretty interesting that, the thermal RECs really take a product that is a New Hampshire indigenous fuel of whether it's one of these three, doesn't have to be any particular one of them. All three have the exact same thing. And it brings it down to a very competitive fuel that beats all the fossil fuels. So there we are. Questions. And Charlie, do we have any that are written out there? Anybody want to? People can pipe up as well.
There was a question with smaller systems, whether having thermal storage engineered into the system affects the process or the design of the BTU metering. And I commented that it shouldn't. You just put the meters between the thermal storage and the building, as opposed to between the boiler and the thermal storage. Because again, what you're measuring, heat that is actually being used by the building itself, the quote unquote useful thermal energy, is what you base your RECs on. And that term, useful thermal energy, is defined in statute. Jim, you're the engineer. Maybe you've got a little more to add on that one.
Not an engineer. I just play one here on these
Okay.
webcasts. But no, I'll say yes. Yeah, I agree with you. And basically, an engineer has to approve these systems. So not only does the boiler system need to run properly, but now an engineer has to come in and say, I like the way the BTU meter was set up. This is going to be accurate. There's places that, there's been times we put the sensor in the wrong place, or, with a flow sensor or whatever. Sometimes flow sensors don't get a full reading because you need so many feet of straight pipe before it can actually get that proper reading. So an engineer will come in and say, this is good. This is a workable system. And again, if we don't do it right, it will be changed. Any other questions?
Hey Jim, this is Carl. A quick comment about the BTU meter. This is an area that we see a lot of problems with flow transducers not set up properly, or temperature sensors not being in places that are representative for what we want to measure, or not applying the proper amount of thermal grease. I mean, it's an area that's a big challenge. And if budget is no concern, you can always put a BTU meter at the boiler output, and then put another one between the thermal storage tank and the building. And obviously, the difference would be the thermal losses from the tank.
Yeah.
Again, if budget is no concern, I mean, you can do that, and hopefully commission the meters properly, so this way you get accurate readings. Otherwise, they will be way off.
Yeah, I think most of the time we're metering outside of the tank. So there's the buffer tank boiler relationship, and then there's the relationship between the buffer tank and the building, and that's where we're measuring. It's in that realm. So because you can easily be submitting heat in from the boiler directly. It's just the way we do it with the three-way valve. So I think it's just on the other side of the three-way valve that we typically are measuring. So
yeah, you got beautiful drawings. I mean, you can show it there. The problem is that when you have multiple boilers, the customer complains about the cost of having multiple BTU meters on every boiler. So back to Charlie's point, you can put it between the tank and the building, and it's just one meter instead of multiple meters. But again, if you want to watch the system more closely, more meters make you able to continuously commission and observe the operation of the system, the controls, make sure that the boilers are running near full load before they switch from one boiler to the other. I mean, there's a lot of benefits from more collected data in terms of the ongoing commissioning of the system.
Good point. Good point. A number of we've now aligned ourselves with Wilson Engineering that's been working with. Yeah, they actually have a database system that you have to have a database on site, but you also don't want to have that just available on site. It's good to have it in a secondary location. So we've also worked with them, and they now have a way that they're looking at that data as it comes in. And if it suddenly stops for a day or so, they'll call up and they'll say, hey, there's a problem here. So And sometimes that's because the boiler stopped, and maybe somebody doesn't know about that, or who knows what it is. But usually it's because the BTU meter somehow has a problem, and you're losing money if you're not metering everything every day.
Jim, there's a couple other additional questions. Lisa Drake asks, can you speak to the market price for T-Rex? How is supply and demand, and how does that impact the price? Is it variable?
Charlie, go ahead.
Lisa, the ceiling price on T-Rex in New Hampshire is around $26 now. It was $25 when it was originally enacted, and it goes up annually by 1/2 the consumer price index per statute. So that puts it at around 26 and change in 2021. The Rex are selling pretty close to the ceiling right now because there is a deficit of supply in the marketplace relative to what the statute requires retail service providers to purchase. It's pure supply and demand economics. If you have much less supply than you have demand, those Recs are going to trade very close to the ceiling price. The minute the supply gets close to or exceeds the demand, you're going to see those rec values come down rather dramatically. A few years ago, when Concord Steam was still attempting to rebuild their combined heat and power plant that was heating or would heat 180 commercial and institutional buildings in greater downtown Concord, there was a concern that massive quantity of T-Rex that project was going to generate, swamp the market and depress prices. That project never came to fruition. More recently, had Dartmouth College moved ahead with their plan to construct a state-of-the-art wood chip fueled central heating plant for the college campus in Hanover, that project would also have generated very significant quantities of T-Rex that might have had the effect of depressing prices. But I don't see projects anywhere near that scale on the horizon, at least that I'm aware of. And so I think it's realistic to expect values will continue to stay relatively high for the foreseeable future. Now, if oil prices go through the roof and all of a sudden there's tremendous new enthusiasm and interest in modern wood heating, and wouldn't that be a good problem? We may see a rush of new projects, and that might potentially drive the price down. But if that happens, it means the RPS is working. And so that's a good thing. And we just, we deal with it if and when we cross that threshold.
Mm-hmm.
Go ahead, Jim.
I've got nothing more to add to that. I think you're right on track. Andy Duncan has asked a question. Any capital cost scenarios with heating oil replacement systems showing the 7 to 8 year payback? In other words, it's a question, do I have something like that? And yes, I could supply that. Is there additional capital cost incentives such as USDA REAP? Yes, it is. Usually we have some kind of a rebate or some, there could be even grants involved, like there's an annual grant from the NHPUC that some of our systems have qualified for. Usually that covers no more than 30% of the cost of the installation. But very often it's very helpful, especially, those are for big systems too. I think the minimum grant is $150,000 for those, which means it's going to be a, $450,000, $500,000 minimum. Probably means a high school or a situation where you need to build a boiler house because there's no room in the building to put a, kind of a biomass system in. So some of these costs can be kind of excessive, but it helps to bring it down into a realistic realm of like the 7 to 8 year payback. Some are going to be a little more, some perhaps will be less. With your typical smaller industrial or school situation, there's a $75,000 maximum rebate you can get from the state through the PUC again. That's pretty natural, pretty much, happens just about every time. In other words, without any real debate. Usually it's not over what do you call that, subscribed, where there's too many people fighting for not enough dollars. It's been pretty well on target. We've been lucky that way, I think, overall. The USDA REAP has been possible. I haven't seen too many do that, but it is something that is feasible. And I think, I don't know exactly
And just
why.
important to point out that that's only for rural small businesses and agricultural enterprises.
So schools would not apply.
Unfortunately, REAP does not, cannot provide grants to public or nonprofit institutions. There are other programs that USDA administers. The Wood Innovation Grant Program and the Community Wood Energy and Wood Innovation Program, two separate programs that can provide capital grants for modern wood heating systems in nonprofit and municipal or public institutions and applications. And
that's good.
who has additional questions about potential sources of funding, feel free to send me an email or give me a call. I'd be happy to fill you in. I did want to point out, given that we got a question from Andy Duncan, that the New Hampshire Rural Renewables Program that is administered by Lakes Region Community College in partnership with USDA Rural Development does provide technical assistance to any business, rural business, small business, or agricultural enterprise that may be interested in exploring modern wood heating options. Without charge, we can do a fairly high-level feasibility analysis. And anyone who's listening in today who wants to take advantage of that opportunity can contact Andy directly, or just Google New Hampshire Rural Renewables, and it'll take you right to the information page for how you submit an application. It's a very simple, straightforward process, and it provides assistance in modern wood heating, solar applications, as well as energy efficiency.
That's really good help. It can be confusing with so many, it seems to be a lot of moving parts, especially when we started to throw in the thermal RECs. It's like, wait a second, I can get a grant and I got this and that, and how does this all pay back? And it's hard to map out. And there's also, I think sometimes people look at it in different ways. I always like to look at it, or look into the forward, look into the future, where a lot of people say, well, what's my payback? I'm going to look backwards and I'm going to see what I was paying, and now what am I going to pay? But actually your situation, very often you've got brand new boilers you've got to buy. So in other words, you're going to either buy this boiler or that boiler, fossil fuel, or maybe a combination of fossil and biomass. And then you've got to throw in the future cost of that system, whatever it is, the fuels, and then the rebates and the thermal RECs and so forth. So it's to lay it out I'm sure that's something that Charlie does, and we'll do that too. There's very often that's one of the scenarios that just people appreciate seeing all laid out as option A, B, C, and sort of see a flow. And then what's the future cost of energy going to be? How stable is it going to be? And that's a really crazy road to go down. You end up with, is oil going to be $3 a gallon or $5 a gallon? If we look at this chart, watch the graph go up. Nope, it's going to plummet right back down to $2 or whatever. It's just, you can't predict that. So, but you have to look at the future and say, at least in the 10-year range, I'm going to be able to look back and say, it didn't cost me any extra to go biomass, and I feel good about going with biomass. So that's I think an easy thing to pretty much assume. Any other questions? Well, I thank everybody for attending today. I wanted to point out again, next week, we're going to do these through the month of March now. We're going to end up on March 25th as our last one. So we've got 4 more to go. And this one on March 4th is going to be talking biomass with clients and stakeholders. It's especially intended for engineers, design professionals, as well as facilities directors that are interested in bringing up biomass for their organization. and to be able to talk about it rationally and realistically. And I'm talking about very honestly about what the situation is. There's a lot of information out about sort of the negative, don't burn those trees. And what we're doing here in New Hampshire and Vermont and you know, in the Northeast overall, is very high efficiency, very environmentally friendly in so many different ways. So we'll be confronting that next time. Like I say, after that, we're going to be talking about school systems. There's also going to be one about recovering flue gas from biomass systems. And the last one is going to be about nursing homes or sort of big operations. And we'll be ending up and then probably doing this again in the midsummer. But we appreciate everybody tuning in, and this will be recorded. You can always go to our YouTube channel and see every one of the webinars we've had. This will be our 10th one right now online, and you're welcome to go check those out. I always point out the one on top. It says last week, but it's actually been a while ago. But the role of forest-based energy, biomass energy, and addressing climate change is this one up in the upper right here. And that is an excellent program if you want to understand more about biomass and how it fits into the whole climate change scenario. I think it's a great one. There's a gentleman named Bob Malmsheimer who spoke at that, who's an expert in this kind of thing, and did a great job of putting the whole thing in perspective. So Charlie, I want to thank you for being here today with us. Thank you for speaking. And
thank you.
Yes, well, good. Hey, if anybody wants to get in touch with Charlie again, you can, there's his email address. You can also write to us different ways. So we're welcoming your questions and comments. All right. Well, thank you, everybody. Appreciate you being here.
Thanks, everybody. Take care now.
Good day.